Welcome to a lesson with Dr. Powell. Let's go back to the continuity idea for a minute. So if I have a curve like this, and what if there are no holes at all? Well, what if this x value were 2 and the y value were 4, right there, and this function were f? Then we could still say the following. The limit as x approaches 2 of the function f of x is equal to 4. There is no hole to fill, but if there were a hole, then we would fill it with precisely the value of the function itself. This is always true for a continuous function, because for a continuous function, every single point, if made a hole, so you take out that y value, the y value you put back in is precisely the y value you took out. So that's what makes a continuous function. So if you make a hole, the y value that you removed is the y value to put back in. And especially if this is represented by something where it's in the domain of the expression itself, we're good to go just to plug in to find it out. So essentially, in some sense, if you have a continuous function that's well defined in the domain, to find the limit is nothing more than plugging in. So for instance, what if we had f of x is equal to square root of x plus 5? Then if we were to what if we want to compute the limit as x approaches 4 of f of x? Well, this is a continuous function and well defined around the point x equals 4, meaning so we can just plug in. For continuous functions, taking limits is nothing more than just plugging in. So we can plug in the 4 in for x, and we get square root of quantity 4 plus 5, which is the square root of 9, which is 3. Hence, we've just computed the limit of a nice continuous function. Thanks for watching.